So, what are parameters? Parameters are the numerical value inside the model that is learned from the training data. Role of the parameter is that it controls how the model transfers input into outputs. They directly affect the predictions. In neural networks, the parameters are the values that get updated during the training to reduce the loss or error. If we look at this neural network system, here we have an input layer, a hidden layer, and an output layer. So this particular portion is called hidden layer. These are output layers and input layers. What happens here is when you place the neural networks neurons here, what happens is for each and every neuron, a weight is passed to the next layer. Suppose this is an input layer and it is passing a weight to the next hidden layer that connects. And here the model gives a weight that is called parameter. So each and every single weight is equal to parameter. Also, the biases are the number of parameters as well. So here, if we look at the weights, the weight is a numerical value that represents the strength of the connection between two neurons in a neural network. This line is very important, I think, because it sums up the definition of the weight. So if you look at this neural network, here it's an input layer and it has a hidden layer. So how strong the connection between these two layers, we're giving it a number, and then that number is actually the weight. Suppose it is weight 1, which is also referred to the bias. So it is also referred to the weights. So if we look here, then it would be titled as a weight. This would be weight 1, this would be weight 2, this would be weight 3, this is going to be weight 4. So what does these mean? These mean that the weight of the numerical value that represents the strength of between two neurons, how strong they lie, the weight number represents that. Every connection from one neuron to another has one weight. During training, the model adjusts these weights to reduce the error in the prediction. And mathematically, a weight multiplies the input value, which can be written as y is equal to wx, where w is the value of weight, of course, and x is the input value. The collection of weights in the network forms a major portion of the model's parameters. So, what are the bias? Bias is a numerical value added to the weighted sum of the inputs. So, each neuron typically has one bias. The purpose of the bias is to shift the output value so the model can better fit into the data. Without the bias, the model's flexibility would be limited. Mathematically, the operation becomes y is equal to wx plus b, where y is the total output value, and the w is going to be the weight, x is the input, and b is going to be the bias. Here we can see that with each and every input that we get, we have to add a bias layer that gets added into each hidden layer. Not exactly, it doesn't really have to be hidden layer. It just has to be connected with the next layer. So how the parameters are calculated. The total number of parameters in a neural network depends on how many neurons are connected between the layers, which is also called the hidden layers. It depends on the hidden layer, output layer, and the input layer. In a fully connected dense layer, every neuron is in the previous layer connected to every neuron in the next layer. So each connection has one weight and each neuron in the next layer has one bias. As we can see in this picture, that it has 1, 2, 3, and 4 layers, but here the biases are connected with the next layer, like this. So to calculate the number of parameters of a dense layer, the formula is the total number of parameters is equal to the input neurons, the output neurons, and plus the output neurons. So if we look at this part, for example, if a layer has 4 inputs, as we can see that it has 4 inputs, number 1, number 2, number 3, and number 4, has 4 inputs, and it has 3 output layers, output 1, 2, and 3. So the number of weights is going to be 4, as there are 4 layers of input neurons. There are 4 input neurons, so it's going to be 4 into the number of output neurons, which is 3. So if we multiply, we get 12. Since there are 2 output neurons, the biases would be connected here with the output layers, so there are going to be 3 biases. So the number of parameters is going to be 12 plus 3, which is going to be 15. So how parameters look in a model? When you build and run a neural network model in a framework like, I personally use PyTorch, but you can also use Keras, automatically calculates the display of parameters count in the model summary. We usually see that the total number of parameters, trainable parameters, and non-trainable parameters. So total parameters mean that all sum of the weights and biases in the model. Trainable parameters are one which update during the training, but it's static. It's not static, it's dynamic. And non-trainable parameters are fixed values. These are called frozen layers and batch layers. So mathematically, total parameter is going to be trainable plus non-trainable parameters. So in summary, it helps to understand the model size, model complexity, and memory usage.